Let's continue our studies of Samba implementation by focusing on the Samba server itself. So thus far we've looked at the clients, the important ones that is, find SMB through SMB tar. However, Samba server is the reason why we're here. It provides the ability to look like or interact with Windows servers as a Samba CIFS server. In other words, making your Linux or Unix box appear to be a Windows box on the wire. Its primary configuration file mentioned earlier is beneath etc samba, and it's smb.conf. This is where the key directives are placed. Now there is a program named SWAT, Samba Web Administration Tool, that is installed as a separate package, which manages the etc samba smb.conf file, which we'll be looking at to manipulate the directives that are important to us for our Samba server. But until then, we'll just take a look at the default configuration file and then move on to SWAT installation. So let's go to the shell, and on our local system, Linux CBT Serv 1, we'll navigate into etc samba lsltr, where you'll see two files, smb.conf and lmhosts. As mentioned, the lmhosts file is similar to, or functions similarly to, the lmhosts file within a Windows environment. It provides LAN manager resolution, so LAN manager names to IP addresses. The default file contains one entry for local hosts. Apart from that, there are no entries, but you could insert entries for LAN manager boxes on your network, and whenever any of your Samba-related tools make a request that is to communicate with any of the systems listed in lmhosts, through the Samba engine, they will consult lmhosts. By the Samba engine, we mean whatever Samba client that's in use will make use of the lmhosts file. Apart from that, again, the key file is smb.conf. So let's take a look at it. We'll use nano space smb.conf. It's heavily commented, and the directives are well explained. Now in this global section that you see here, and the sections are denoted like sections in INI files in Windows, we see key directives that describe or define this system on the network when the Samba services are started. They include the all-important workgroup directive. If you recall from older versions of Windows, whenever you set up networking, you had to define a workgroup or accept the default of workgroup. Well, for this configuration, the default is mygroup. For other Linux distros, you may find that it's tux-net or tuxnet or something along those lines. The idea is you should have it match the workgroup or domain name that's in use in your environment. And again, from the shell, we're able to determine using SMB tree that the workgroup is Linux Genius. So with that said, we will change our workgroup setting to Linux Genius. The string that's returned here is just that. It's a text descriptor that's returned and displayed whenever you query the Samba server from a Samba client, such as Windows or Linux. So it's just a descriptive string. And again, the commented line before the uncommented directive explains the purpose of the directive. And also, as is common with most Linux text files, configuration files, hash marks denote comments. Security mode. Samba operates in multiple modes: user, server, Active Directory, and so on. Those are the three key modes. In user mode, you need to have a Samba user defined for every local Linux user. Let's just note some of these things. Samba server modes. And these are the key modes, not all of the modes. User, server, ADS for Active Directory, which allows your system to participate in Active Directory. In user mode, one Samba-defined user is required per Linux user. And there is a way, or there's a means for defining Samba users that translate to local Linux users. Ultimately, Samba provides access, file and print access, and in granting file access, Samba needs to speak Windows language, which is a different language for authentication. The passwords are kept using a different algorithm, and it needs to translate those users using its facilities to local Linux users who can be looked up in etc password and etc shadow. So in user mode, one Samba-defined user is required per Linux user. Also in this mode, authentication is handled by the Samba server. So authentication of user or users is handled by Samba server, which means when a user connects to your Samba server, the Samba instance consults its database of users and translates those users to local Linux users. In server mode, I will list server/domain, which is another mode that's similar to server mode, but in domain mode, the authentication happens by any, or is performed by any domain controller. But in server mode, as well as domain mode, either mode, authentication is handled by the Windows NT 2K, 2K3, 2K8, or what have you, server. However, it still requires, in server mode as well as domain mode, the requirement is still there to maintain a local user account database. Still requires a local Samba defined, as we mentioned above, user account database. In ADS integrated mode, authentication is handled by the Active Directory setup, so it's handled by Active Directory. And in addition, when coupled with WinBind, when used with WinBind, locally defined Samba users are not required. And that's because WinBind has a facility to allow remote users to log in and take advantage of Linux services. In other words, it provides a translation between the remote users and local IDs. It automatically assigns IDs, and we'll look at that when we get to the WinBind section. But for now, we're focusing on user and server setup to authenticate locally as well as via a server. The server could be an XP box, NT, 2000, 2003, 2008, you name it. These are the main modes: user, server, Active Directory. Server and domain function similarly, but again, in domain mode, multiple servers such as a PDC, BDC, Windows system may authenticate requests, whereas in server mode, a specific server known as the password server is responsible for authenticating the connecting user. But when it's all said and done, let's just note, ultimately, with regards to providing access to files and printers, but particularly files, but printers are also files, ultimately, users must authenticate to the local Linux file system. So they must pass the test of gaining access to files within the Linux file system. The permissions must be granted, whether it's via WinBind, and we use the chown facility or change mod to allow WinBind users access to directories, or whether it's via a local Samba-defined user accounts database which maps out to a local Linux user. The user ultimately has to be granted access to the local file system. Otherwise, Samba will prompt, and the user will be then asked to specify appropriate or valid credentials. So with that said, let's continue perusing smb.conf. Samba has many features, including the ability to restrict connectivity to its services to specific IP addresses. This option is currently commented out, but if you'd like, you could restrict communications with your Samba server to specific subnets. And here we see examples of how to indicate multiple subnets. 2 RFC 1918 and 1 loopback subnet. Whether or not printers are to be loaded, it's set to yes by default. Print cap settings, the printing engine defaults to cups. Cups accepts the job in raw format, so it should be already set up by the application that's sending the job to be printed, or it needs to be in the appropriate form for the printer to print the job. Guest account, and it's suggested that you uncomment this if you want to support a guest account. And if you do want to support guests, guest will be translated to nobody, which is an account in the Linux world, which is equivalent to anonymous. However, you can define your guest account to be whatever you'd like it to be, but generally it's not a good idea to enable guests. It's better that you allow each user to connect distinctly. For each connecting Samba client machine, a log file is created with the machine's IP address or its host name, and it's created beneath varlog Samba. Earlier when we were discussing logs, we did mention that Samba maintains its own directory hierarchy beneath varlog because it has the potential to house many files depending on the number of users that connect to your Samba server. So this variable %m means to Samba to record the name of the file using the machine's IP address or its host name. And that way you can determine what connections were made by various clients in your environment. The maximum log file size is set to 50 kilobytes. In a busy production environment, this is not practical. It should be much larger, such as maybe 50,000 megabytes or 50 megabytes per connecting users if you really want to keep track of the resources that have been accessed by connecting clients. Whether or not to use a password server. And this is a mode that's used when you set security equals server. Again, when security is set to server, you're basically saying you want a given server to cross-reference user connections. It still doesn't exempt you from having to maintain a local user account database for translation purposes, but the onus of confirming credentials is then placed on the server that's referenced by the password space server equals directive. In the case of domain controllers, password server equals asterisk will work because it means any server, PDC or BDC or any number of BDCs that are able to respond will suffice. But in the case of a single server, such as an XP or 2003, 2008 server, then you need to indicate that server, and you'll still in either case need to maintain a translation locally on the Linux system, which we'll get more into. If you're using Active Directory, you need to specify a realm which usually maps to the Active Directory domain name, which is usually some form or some derivative of your DNS infrastructure, such as linuxcbt.internal or ad.linuxcbt.internal. Now, we've been talking about the local user accounts database. It's stored using by default a format known as TDB-SAM. This is the default format that will be used when we use the SMB password utility to create and modify and update local user account mappings, which ultimately get translated to local Linux users. Interfaces. You can determine which interface Samba or interfaces Samba should listen to. Another neat feature, because often you find with Linux systems that they are multi-homed, meaning they have multiple physical interfaces, and you may or may not want Samba to be available on all those interfaces. The default behavior is for Samba, of course, to bind to all IP addresses or all zeros, quad zeros, but you can control that using the interfaces directive. Whether or not your server is a master browser for the subnet, whether or not it's a domain master, domain logons, login scripts, login path, and we'll just keep scrolling through, whether or not Win support is to be enabled. When Win support is enabled, your Samba server becomes a Win's server. But again, we've mentioned in other versions of LinuxCBT that Samba's Win support as a Win server in the 3.x release of Samba is still pretty weak. For example, it doesn't support replication with multiple Win servers, so it's currently still suggested that you don't make your Samba server a Win's server, unless of course you're setting up an environment with no Windows servers and you need basic Win's functionality for the clients. So you may have a small office or a small department within an office with, let's say, multiple Windows front-end systems, desktop systems, that use your Samba server as an emulated domain server. In that case, then the single Samba server can function as a Win server. But this Win support directive means whether or not to set your server as a Win server. It's commented, so it currently will not run as a Win server. And conversely, if you want your Samba server to be able to populate its record, meaning its name and its IP address, to a Win server to function as a Win's client, then you turn on the directive Win's server. And then you specify one or more Win servers, and Samba will publish its name and IP address in the Win server database. There's a Win's proxy feature where your Samba server will answer on behalf of non-Win's capable clients requests for network resources, for names. In today's networks, you'll find that most, if not all, client systems are Win's clients or Win's capable. DNS proxy. This allows you to look up NetBIOS names using DNS. The default is set to no, but you may set it to yes if your DNS and Win servers have similar database mappings. There are some scripts below to control domain functionality, adding, removing users and machines if you set up the Samba server to be a domain controller. And then you've got the important share section. So after the global section, you'll find the share definition section. Each share is denoted with a header, an INI styled header, such as the following. By default, Samba automatically shares users' home directories, providing the user appropriately authenticates to the Samba server, whether by way of Active Directory, a domain controller, or using the local configuration file. So long as you're able to authenticate to the server, it will publish a home directory for you, and you'll see that directory, and you'll be able to use the directory. If your server is a domain controller emulator, then you'll need the net logon share. This is a requirement of older style Windows NT servers. Also, if you'd like to have a profiles directory, if users make use of roaming profiles. Printers are automatically shared, so any defined printers on the Linux box via cups will be shared with your Windows community. Temp will not be shared, but if you comment it or remove the comments, it will be. Read-only will not be set to no, and for each share you can define myriad directives, including the path to the share, which may or may not be the same name as a share, just like in Windows, whether or not the share is read-only, if it's available to the public, or if it's hidden. You can even limit shares to specific IP addresses, something you can't do in Windows. Here's another commented example of a share, public. An example of a private printer. This printer is accessible to the valid user Fred. Here is an example, it's commented of course, of a private directory which is accessible only to Fred. Has a comment, a path, valid users equals Fred, meaning if you're not Fred, unless you know Fred's password and username, you will not be able to see the Fred's directory share. So Samba has this way of dynamically publishing shares, and it's not doing it in a hidden sense where it uses $ like with Windows. It on the fly publishes the shares, such as the home's directory share per user. There's another example, PC Home, and we wrap up. Here's another example where a mask is set on a share that's commented currently for items that are written or for items that are created, that is, in the shares directory. They're all flagged with 765. So you can also influence the default permissions that are applied to directories beneath shares files beneath shares, and so on. Now with that said, to get a better view of these directives, we should install SWAT. So our first task is to install SWAT. That's the Samba Web Administration tool. And we'll use, of course, yum install, and we can get the package name from the browser, and there it is, samba-swat for 3.025. And this will install Samba SWAT, and we will ensure that it starts and then connect to the browser, manipulate the settings, then start the Samba server and attempt to interact with it. Let's copy and paste this to the shell and move forward. We'll exit this interface. We'll save the changes. We updated the domain name, and we'll Control-Shift-V to get Samba SWAT installed in our system. And this is consulting the repository. And now it's installing Samba SWAT, client, common. Again, we're doing this on Serve 1, Linux CBT Serve 1, as opposed to Serve 4, which already has client and common installed. And in fact, let's go ahead and yum install on that server as well. As you can see, the package is being updated before we move forward. And the new version of the conf is created, but as RPM new, to indicate that it's a new version of the file. But yum also updates packages. In this case, you have yet to see the update take place automatically, but the version that came with Red Hat Enterprise 5.0 is slightly off, and as a result, yum knows it and it updates it. So let's get a simultaneous installation going here on the remote system. This will have less work to do because the other packages are up to date. In this case, you see it's installed Samba SWAT as well as Samba. It didn't need to install common as well as client packages. So the remote system is complete, and an RPM query all grep Samba will confirm as such momentarily. There's common, client, the main package, and SWAT. And on our local system, it's complete as well. So with that said, let's RPM query list Samba SWAT to examine the contents of the package. This dumps tons of files. Samba SWAT includes comprehensive documentation for each and every directive that you may enable or disable within Samba. The documentation is accessible via the web browser. So once you have connected to Samba SWAT, you will see links per directive to be able to interact with the directive to make determination as to whether or not it's something that would be beneficial to your environment. Now SWAT's controlled by ZynetD, so we need to ensure that it's enabled in ZynetD. And it has a main binary. You just scrolled over it. Of course it has a main binary located in user sbin, and documentation is located beneath user share SWAT. So with that said, let's nano our ZynetD entry, and we're always looking to change disable equals yes to disable equals no so that the service will start. And just a brief word about the service. It is a stream-based service, which means it's TCP based, and it listens to port 901 or 901. It currently or by default will accept connectivity only from the rootback adapter or from the local host, and it will run as a user root. This is the path to the binary, and if you fail to log in, the user ID you supplied will be logged. Let's save the changes and then execute service ZynetD restart. To confirm that it's running, netstat ntl grep 901, and we should see that it's running. So in addition to installation, we've nanoed etc zynetd.d SWAT, and then we've set disable equals no so that the service will start. Then we restarted the ZynetD service using service ZynetD restart, and we followed that up with a netstat NTL grep 901 to confirm that the port has been bound. So with that said, from the browser we can connect to the SWAT instance. Let's just use the NTP interface, which we opened some time ago, and this was the page we were waiting for earlier in our studies. Navigate to the US section and find a time server that's near you and set it up in your NTP configuration. So to connect Samba SWAT, localhost 901. This will prompt us for authentication by popping up a window, and we'll authenticate as root. Now once we've authenticated, we'll see the Samba SWAT interface. Here it is, welcome to SWAT, or to Samba. It provides the main menu items in the upper section of the menu, and below you'll find links to documentation and the key configuration files that constitute the Samba environment. The main daemons are laid out. They include SMBD, NMBD, and WinBindD. NMBD is the NetBIOS name server. Whenever a request is made for your server to respond, this daemon makes the server known to the client, and then the actual file and print sessions are handled by SMBD. So NMBD takes care of the NetBIOS related services. WinBind takes care of integrating your Samba instance with Active Directory for the sake of being able to log in totally authenticated against Active Directory and not having to define users locally. As far as configuration files, this is the primary file. It's a monolithic file like with SendMail and many other programs. LM hosts for resolution, you can place items there or entries there. And SMB password, which is the file which maintains the local user account database. There are administrative utilities, SMB control to send messages to running daemons, SMB password for managing user accounts that are maintained locally, SWAT, which is this utility, net, we use this utility primarily to add our server to the Active Directory, and other utilities. Here are some client tools, more than the ones we've mentioned. We've mentioned the key ones, and their diagnostic utilities. Of them, the two most important ones include testparm and WBinfo. Testparm tests your configuration file to ensure that it's syntactically correct. WBinfo returns user and group information from remote Active Directory and Windows servers when set in those modes. And there are other links, such as how to do profiles, how to log, generate PCAP files from Samba log files, so that you can trace through a series of events, and links to books, so on and so forth. So the home page is pretty informative, but you'll find the key configuration directives in the global section. The global section is nothing more than a front end to the smb.conf file. By default, it displays in basic view. In basic view, it hides many of the directives that are not important to get the server up and running. But oftentimes you need to launch yourself into advanced view to see those additional directives if there are performance issues or connectivity problems or things that are peculiar to your environment. Basic view again lists the key directives, the workgroup or realm that the server belongs to, its NetBIOS name, optional aliases. Your server can appear to be a different server on the network by publishing one or more aliases, a string, the interfaces that it should bind to. So these are like your base options as it's described. But again, if we expand using advanced, you'll see many more base options and many more options for the other categories. So now we see base options has more options that we have not discussed. Bind interfaces only, NetBIOS scope, display character set, Unix character set, DOS character set. These are all additional items that work well with the default, but again, you may need to tweak depending on whether or not you have trouble. In the security section, a very important section, you need to determine the mode in which your Samba server will authenticate. And here are the supported modes. We didn't discuss share because this is a mode you should stay away from. This is similar to assigning a password to a share, which is outdated and is not secure and not recommended. Server, domain, ADS, and user are the modes you should look to use, primarily user or ADS. Whether or not passwords should be encrypted. Definitely. Secure channel for the client and server automatically. If the server requests it, the Samba server, or if the remote system requests it, whether client or server, the Samba server will attempt to accommodate. The account that's to be used for guest. Guest requests get translated to the local Linux user nobody. And the local Linux user nobody has a high ID. If you grep nobody from etc password, it has a high ID of 65,534. So if a user connects from a Samba client or Windows server to our Samba server as guest, guest will be translated if guest support is enabled to the nobody account. In this case, nobody has 99, NFS nobody has 65,534. So the default nobody account has the 99 ID. The NFS nobody, which we looked at during the NFS section, has the high ID of 65,534. Whether or not users are to be invalid or validated, so you can determine, let's say there's someone who's been terminated from the organization and you need a quick way to deny them access to your Samba server, you can set them in the invalid user list field. Users who are equivalent to admin, who get translated ultimately to root on the Linux system, a list of users who may read and write, the printer administrator, hosts that are permitted access, hosts that are denied access. If the fields are blank, then all access is allowed. If there are modules that are to be loaded to help Samba do its job. Logging options, if you want to change the variable or add to the variable, maybe %m doesn't suffice, maybe 50 kilobytes aren't enough. And again, when you click on help, you're propelled into a separate page which returns the explanation for the directive in a context-sensitive manner. So here we see log file, and it tells you how the log file works, and so on. You can learn more about it. And that's for the log file entry. It just tells you that it's a path to the log file. Protocol options, printing options, CUPS uses RAW by default, so your connecting clients which naturally default to RAW will be able to send print jobs through your CUPS print server directly to your printer. Browse options, this has to do with how your server interacts with other Windows servers on a given subnet as well as within a given domain. Wins options, which we've described. If you want your server to be a Win server, you say yes, or you select yes. If you want to indicate a remote Win server, you specify one or more IP addresses, click on help, and it's again context sensitive. You'll be propelled to Win server, and it tells you how you may use this particular directive. So you can indicate Win server in a variety of ways. The name of the server, :IP address, or just the IP address, or even multiple IP addresses delimited using space. So again, the help is context sensitive. Items related to event log, WinBind, such as how to map out the Windows users to local Linux IDs, etc. And for each of these groups, the advanced section opens up a bunch of directives that you have not seen. Now let's, in the interest of saving time, move forward and look at the share section. The share section is self-explanatory. It has basic and advanced views. When you click on the arrow in the Choose Share section, you see the shares that are available. Click on a share, click on Choose Share, and then you'll see the options that pertain to the share below. Its comment, its path. The path is dynamic, which is why there's no entry here. Invalid, valid, admin, read, write. Whether or not it's read-only, whether or not guest access is okay. Well, for the home share, guest access should not be permitted. Whether or not host specific IP addresses should be allowed or denied. With no entries, it means that all users are permitted at least connectivity, but you still need credentials. Whether or not it's browsable. This is a way to hide the share altogether, not using $ like you do in Windows, but using a special Samba feature which hides the share. And in the case of homes, it's hidden, and it is automatically generated, almost like the way AutoFS makes a directory available at runtime or at request time. And again, there are advanced parameters for shares as well. And if you want to create a share, you can do so, which we'll do momentarily once we get the server up and running. In the printers area, this is the interface that you'd use to define a printer. You can create a printer and point it to a printer that's connected to the Linux box, or connected across the network and just route it through your Samba box. There's a wizard which includes predefined tasks, as all wizards do, such as setting your server up as a domain member, a domain controller, configure a Win server, expose home directories. These are some basic wizards. There's a status section. In here you can determine the status of the daemons. As we see, the version followed by the daemons and their statuses. Not running, not running, not running. And that's true. If we clicked on Start All, momentarily the Samba instances would start up, and then we'd attempt to connect to the Samba instance. Active connections, active shares, open files, so on and so forth. In view mode, you get a bird's eye view of the smb.conf file, with the comments removed for brevity. So here are the items that are important: the workgroup, the string, the log file, its size, so on and so forth. And in the password section, the last tab, this is an area where you can change a user's password, such as root's password, and this is basically a front end to the SMB password file. So you can assign a password, let's say for the user root, and this simply updates the user root's password, not the user root in the Linux system. Now, it said it failed to find an entry because there are no passwords. If we navigate to etc Samba, where we currently are, there was no SMB password file. The file is blank. It contains nothing. In fact, it was just created, which explains why it's 0 bytes. So the Samba instance was unable to change the password for the user because the user doesn't exist. If we go ahead and indicate the password that we'd like to set for the user, simple ABC123, click on Add New User, and then it says below Added User Root. Perhaps this should be bolded so it's obvious. Then return to the shell and relist the contents of the directory. We now see that SMB password is 101 bytes, and when we cat SMB password, we'll see it contains the user root, followed by the string, the NT-compatible string, which represents the user's password. And it also includes the user's ID. This is very important, by the way. etc SMB password maps out to etc password. Let's just note that. etc Samba SMB password maps Windows users to etc password. And you can tell that it does this by looking at the field immediately following the user's ID. Root followed by 0 means this user is equivalent to root, followed by root's password, of course. Also notice that the secrets.tdb file, this is that TDB SAM file that we discussed briefly earlier, has been created. So it contains the user accounts database in a binary format, which is not visible to us. In fact, the file secrets TDB will tell us that it's a database file. So again, we have one user, and if we connect from a Windows system or a remote Samba instance as this user root, we'll then be able to interact with the Samba server as root. And if you want to add another user, such as, let's say, Linux CBT, let's go ahead, find that Samba window. By all means do so. Just go ahead and type in the user's name with a password. And by the way, the password does not have to match the Linux user's password. Simply the username and user ID. So now this user has been added, and let's take a look at the contents of SMB password. It's now 208 bytes, and we will see that there's a new user in the SMB password file named Linux CBT with the ID 500. Now let's grep Linux CBT from etc password, just to show you that indeed ID 500 in SMB password matches ID 500 in etc password. And it's not just a coincidence. It's done by design to ensure that when a connecting user authenticates as Linux CBT, regardless of Windows password, they are able to be translated on the Linux file system as the user Linux CBT. It's done for that sole purpose of mapping the NetBIOS user to the Linux user. And you can control it using this interface or using SMB password. So for example, let's grep student from etc password. There we see student 1. If we use SMB password with no options, it prompts us for a new password for the currently logged in user. However, run it with help and you'll see how you can add a new user to the database. So SMB password with the A option, followed by the user's name, student 1. Now it prompts us, we'll set it to ABC123. And now when we cap the contents of SMB password, you'll see 3 users. And also, coincidentally, student 1 has the ID 501. Let's grep again student 1 from etc password just to confirm that, and there you see the user has 501. So the mappings are done purposefully. Now with that all said, we need to start the Samba server and attempt to connect. It doesn't make sense to go through all these directives to not be able to use the service. So through status or from the shell, you can attempt to start the server. Go ahead and click Start All, and this will attempt to fire up all of the services. And we'll see how it returns. If it's successful, then we'll confirm either way, pass or fail. Now it appears to be running. From the shell, let's confirm. Service, and again, the service is located in etc. All the services are initd, and it's SMB. When you start the SMB service, it automatically starts the NMBD service. So it's PSEF grep SMB, and it starts multiple instances. And let's grep NMB. It's also running. So by starting the Samba instance, it'll cause NMBD to be started. And also WinBind is running, although it's not currently configured. So Samba is up and running, which means we can attempt to connect, and if we were to use SMB tree to try to enumerate the contents of the network, we will see Linux CBT Serve 1. There it is. It has an IPC or inter-process communication share, which is a default share published by Samba servers, including Windows. It doesn't show the home share, but when you connect, it'll publish the home share. So Serve 1 is up on the network. From a Windows perspective, we should be able to interact with it. Now, we do have a Windows box available on the network that we could test. But to connect to it, we'll need the RDesktop utility, which is on our, or in our repository on the Apache server. So let's search for RDesktop. There it is. And it's 141. So from the shell, we'll just use yum install. And this will install our desktop momentarily. And in our notes, we'll just note or task 2, install our desktop and connect to Windows XP to test connectivity to Samba. So to do so, we simply execute yum-y install our desktop, which fetches it from our repository. Let's confirm at the shell what's going on to see if it's successful, and as you can see, it has completed, which means it's installed. An RPM query list of our desktop will reveal what's going on momentarily. And if we scroll through, we'll see that there are many files, but the key file is in user bin, which is accessible to all users. Documentation is included, a man page is included so that you can see how to use our desktop, and it has support for multiple languages. If you execute our desktop with no options, it dumps the usable options. The newer versions of our desktop supports all sorts of redirection features such as COM port, LPT ports, parallel ports, floppy ports. Redirections that are not so critical nowadays but nonetheless still work. Now when connecting to a remote system, it's important that you indicate the resolution of the screen, or F for full screen, the bit depth to control how many colors are returned to the screen, and that's usually using the A option, as well as the host name. So we're going to execute our desktop -F -A, let's set it to 16 bits, space the server's IP address, and optionally the port. Now we've got a system on the network that is, we'll use SMB tree again, that is running XP, and it is named Linux CVT Win2, a system that we attempted to connect to with one of the SMB clients, perhaps even SMB client itself. Let's connect to this system using our desktop full screen A16 for 16 bits or 65,536 colors, and the IP address of the remote system, which is 75.176. You can confirm it, of course, by attempting to ping the host. This will pull up a full screen momentarily for Windows XP on our desktop. The user in which you are logged in as on your Linux box will be supplied, as is the case here. We may then log in as a user. Let's see if we have credentials as this user. And it doesn't allow us, so we'll try to log in as administrator, which we certainly have access to log in as, and momentarily we'll have an administrative desktop. So here's our desktop. It contains different programs from previous studies, and we will attempt to look at the network using My Network Places. We'll maximize this. We'll wait for it to refresh. It's taking a little while. Sometimes F5 will do the trick. And nothing, so we'll try again. Sometimes refresh takes just a little bit. We'll try View Workgroup Computers. There we see the computers. That's View Details. So we've got Serve1, Win1, Win2. These two systems are Windows systems. Win2 is what we're currently connected to. The Serve1 box is a Samba system. Now notice when we double click, it prompts us, it asks us, who are we? We need to tell it who we are. We're going to say that we're the user root with the password ABC123 connecting to the system. And now you see root's home directory published, just like that, with printers and faxes, albeit they're none defined. So now we can connect to root's directory. This is root's home directory, and copy items from the server to our local system. So let's go ahead and copy something to our local system that's of a reasonable size. Here's something that's 10 megabytes roughly, a test file. And we'll copy and paste it to the desktop. This will copy it from the remote system at LAN speeds. And we can also rename it, copy it back. We now have full read-write access to root's directory, and if we open the PuTTY session to the server, we'd see the file that we've returned with the appropriate permissions. Let's find the PuTTY instance and connect to the server located at 75.10. We'll log in as root. And in LSLTR we will find the file. Let's check the directory. And we should see test return towards the top. There's a copy returned. And it was not updated. We didn't make any modifications. We simply renamed the file, which preserved the original timestamp information. And as you can see, Samba wrote the permissions as 744, which can be adjusted for the home share with respect to what items are written as. But nonetheless, we've authenticated to the remote system using user base authentication. Let's log off for now or disconnect. We'll reconnect momentarily. User base works exactly as we've mentioned. So long as you use SMB password or the interface, the SWAT interface, to update the SMB password file, you'll be able to authenticate as these users. But the maintenance of this file can get out of hand as your user base grows, which is why you may want to consider Active Directory authentication and integration to centralize or keep your users centralized, because password management of this can become a nightmare. We have 3 users, and if they decide to change their passwords, it all has to be updated in 2 places. One perhaps in Active Directory, and the other place being the Samba password file. So user base works as follows. If you set it to server with a password server to authenticate against a remote server, it will work similarly, but you'll still need a mapping in your SMB password file to point the Samba user or NetBIOS user to the local Linux user. So that's user-based setup. Now what we want to focus on next is Active Directory base setup.